So again, you're always going to find little bits of this stuff, or maybe even a lot of it, review, but there's going to be the odd thing in there that is pretty calculus specific. You need to like move your desk sideways or do whatever, right? Do whatever you need to do so you can see. Okay, so when we're doing rational expressions, now rational expressions, when there's a variable or whatever in the denominator, right? It changes things. It makes things quite more difficult because you've got non-permissibles and you've got greatest common denominators and all that stuff that multiplication and division don't come with. But when it comes to addition, subtraction of fractions, a lot of fun. Now, you want to factor everything in the numerator and the denominator. You want to cancel any shared factors. So what does it mean to factor things? Like break them up. Okay, so things can cancel. Okay, and then leave the answer in the factored form. Okay, so what does that look like? Well, here's what we're talking about. First of all, you've got your question. Then you factor this. Okay, you factor this. Now I would do that all in one step. This was done in two, but so when we come down to here, this is what we're dealing with, and then you just can cancel stuff out, and then you're left with your final. And sometimes you can reduce at this stage, sometimes you can't, but always make sure. And then we're going to get into talking about non-permissibles as well, because the non-permissibles for this are x equals 0 and -1. And then the one that is often forgotten is 5 as well, right? And students at first are like, what do you mean? There is no 5 in the answer. So why is 5 bad? And the 5 is bad because it was once bad. Okay? It was bad in step 2. Yep. Sorry. Yeah, x cannot equal. Okay? So if it was bad there, it was always going to be a non-permissible. Okay? When we're multiplying and multiplying rational expressions, it's top times top, bottom times bottom. They're really nice. When you divide fractions, make sure you multiply by the reciprocal. Okay? So, 1/2 divided by 2/3, we want to go 1/2 times 3/2. Okay? So you want to multiply by the reciprocal. And it gives you the correct answer. Okay, so there should be an example there, right? And just showing you. Now, you can simplify and then flip it, or, flip it then simplify. It doesn't matter, okay? The important thing is you do both of those, and often they're very contrived questions, I guess you could say, is that there's always going to be lots of canceling going on. And remember, you can cancel within, obviously, and you can cancel, well, this a minus 2 can cancel with this a minus 2. They're not in the same fraction, but they kind of are, because when they're in multiplication, okay, they're basically, you can just get rid of this times sign and put a set of brackets here. And it is all the top divided by all the bottom. Okay, and then again, okay, and then again, make sure you're putting in non-permissibles, and we will skip that non-permissibles on this one. Okay, what's going on here? Okay, so everybody, we need a 3 put down there. Do you guys have a 3 in your book? Okay, good. Typo was fixed. Yeah, I went through the books really well, and I'm like, huh? I didn't see this. Okay, so there is no typo. Now, let's just do this one together. So it's a lot of work before you even get to work, okay, before you're multiplying. Let's factor. What can we factor the top here? X minus 4, x plus 4. Okay. Now, x to the fourth plus 4x to the cubed. What, or 4x to the 3, what could we factor out there? X cubed, leaving you with x plus 4. Okay, so already these are gone, right? Times, let's talk about the other side. We can take out x squared, right? Leaving you with x plus 2. And then we've got another difference of squares. X minus 2, x plus 2. Okay, so these two x plus 2's are canceling. We've got an x squared here and an x cubed here. Okay, so we can basically this is x times x, right? This is x times x times x. So we'll cancel 2 there and we'll cancel 2 there, leaving me with an x on the bottom. So what's left is x minus 4 over x times x minus 2. And then x cannot equal. Okay, 0 is going to be bad. What else? Negative 4 and plus or minus 2. Very good. Okay, now adding and subtracting. Okay, these are the pain. So, and we're not dealing with equations here, because even with equations we can get rid of denominators, but not when we're doing just adding and subtracting. Okay, so for rational expressions, when we're doing addition subtraction, you want to find the lowest common denominator. Now you need to factor it first, and this is kind of an understatement. You should factor first because it does make your life, okay? And for each fraction, multiply the top and bottom with the missing factor to create the lowest common denominator. And this makes more sense, obviously, when you're doing it. And add or subtract the numerator while leaving the denominator the same. Okay, do not add and subtract denominators. They will always stay the same. Okay, now when you first learned how to do 1/2 minus 2/3, most were taught to find a common denominator that both go into, which of course is 6, right? But in fact, I'm going to challenge you to do it that would be more aligned with how we need to do it, that the common denominator would be 2 times 3. Okay? So this would be over 2 times 3 minus this over 2 times 3. So do you see there already was a 2 there? So what do I have to multiply the top by? Just the 3. Okay? And the other one had a 2, sorry, had a 3 already on the bottom, so I had to multiply by 2. So I got to multiply this by 2. Oh, sorry, yeah. Okay? So then our common denominator is actually 2 times 3, right? And then we will go, that's 3 minus 4, which is negative 1 over 6. So this is actually more aligned of how we do it when we're working with rational expressions. Okay, let's, I want to actually, we're just going to skip by this stuff. And does everybody have this example somewhere? Yes? Yeah, okay, and make sure you use a minus sign. Again, there's a typo, but I'm sure it's been corrected, right? You got a minus sign? Okay? Now, this is where you guys should be from math. You have to be at this level of math 30, so why don't we work on this one? Okay, again, don't go anywhere until you start, till you get everything factored, okay? So x plus 5 cannot be factored, but I can take an x out of the bottom, which is x minus 3 is left. Minus, I've got x minus 2, I cannot factor that. I'm looking for two things that add to negative 2 and multiply to negative 3. X minus 3, x minus 1. Yep, x plus 1. Okay, so now we have the factors, just like I did the 2 times the 3. Okay, our LCD is going to be x times x minus 3 times x plus 1. See, that is common between both denominators. If you look, you must make sure, are both of these in my common denominator? Yes. Are both of these in my common denominator? Yes. Okay? So, just like we did with the 2 and the 3, if I go x times x minus 3 times x plus 1, and this I go x times x minus 3 times x plus 1, okay, I just have to keep straight. Well, what did I have to do to this to get this? Well, I had to multiply by x plus 1. So the x plus 5 is already there. I'm going to multiply that by my x plus 1. And students, I've had students say to me, well, now that I have this, do I cancel? Okay, if you go and cancel this, what happens? You're back to the original. So if you cancel it, that would be a good way to know you actually did your conversion correctly. Because this is the same as this. And canceling this proves it. Okay? The next one is x minus 2. And that is going to be multiplied. See, I have x minus 3. So what do I have to? I got to multiply it by x to get this. So I'm going to do the same thing here. Or you can put it out front. Doesn't matter. And don't forget about that minus sign, because it is going to be the thorn in your side if you don't multiply it in well. Okay, so now we just want to FOIL the top, which works out to be x squared plus 6x minus 5. I'm just going to write this all over the common denominator. And now this is a negative x out front, okay? So when you multiply the negative x in, yeah? Sorry, yeah. And when you multiply the negative x in, you get negative x squared plus 2x. Okay, the x squareds are going to cancel each other out. because I have x squared minus x squared, they're gone. So I have 6x plus 2x is 8x plus 5. And on the bottom, my common denominator. Okay, so non-permissible values. We want to walk through the entire question, start right from the top, and factored form is the easiest way to find, because 0, 3, right? I get 3 again, negative 1 there. Okay, and no other ones pop up, so x would not equal 0, negative 1, and 3. Mm-hmm. No, you wouldn't. You would always keep it factored. The only time I would say no is if there was a multiple choice and you can't see this and you go, oh man, they multiplied it all out, so I'll have to go find it. Okay, so we'll go through this one, kind of because we haven't done a division one. But let's just get it so it turns into what we really need. Okay, so all I did was multiply by the reciprocal, which is division. Okay, so let's factor the top. Anything I can take out of the top? Take out a 4x, and that would leave me with x plus 3 on the bottom. Difference of squares, which would be 4 minus x, 4 plus x. This is actually a good question because it's got a little quirk in it. Okay, times two things that multiply to give me negative 1, to give me negative 12, x minus 4, x plus 3, and 20x squared is just 20x squared. Okay, now the reason I like this question is because of this. This 4 minus x and this x minus 4, do they cancel? No. And we've done this, done this in 30, but if you take a negative out of this, that will give me x minus 4. Yeah, we'll just cancel the 4 and the 20, yeah. But so do you see how I can cancel this now? But don't forget about that negative 1 out front. Okay? The 4 and the 20 will divide out to leave me a 5 here. No, just 1. Yeah, like if you have negative 2 times 3, that's negative 1 times 2 times 3, right? You don't want to take the negative out of 3 as well. Okay. What's that? Yep, the x squared. So the x and the x squared go. Okay, so up top I have 4x times x plus 3 all over, I get that negative 1, or negative 1 times, oh yeah, because I like 4s. I wanted to come back, okay? So, and the x is gone too. I did mine different, and that's why I still have it in mind, because I canceled in the end. So that would be, yeah, x plus 3 squared, and then I got the negative 5x, and the x plus 4, the 4 plus x, it doesn't matter, on the bottom. And most times you'll see the negative put here. And always look at your final step. See, the way I had done this, I actually multiplied the 4x in and the 20x, and then I canceled the last step. So wherever you stop, make sure just do a double check. Everything's good to, okay, and then non-permissibles, what x cannot equal what? Okay, so we got plus or minus 4. What else? 0. Okay. People see that negative 3 is bad? Yeah, because it was at one time, remember this, was here. Okay? So negative 3, I know it's in the numerator now, but it was in the denominator at one time. So we've got to put in negative 3 as well. Okay, so and let's just skip the next example. And let's start getting into working with radicals. Okay, so let's get into rationalizing. Okay, it has a little different definition than that in the English language. Okay, basically rationalizing is getting rid of radicals. Most times in 30-1, we always want to get it out of the denominator, the bottom. But sometimes even in calculus, you want to get radicals out of the top. Okay, you don't care about the bottom. Right? So it may say rationalize the numerator. Okay, so you got to pay attention. It was always the denominator in 30. Now it can be either one. It doesn't matter. Just kind of some things to, I guess, be aware of is when you have the square root of an a squared, it's a. Okay, when you multiply, so we're working across here, when you multiply, your a and your c will multiply together, and your b and your d, will multiply together inside. And you may have to simplify and bring some stuff out. Okay, now when you're going to add radicals, you got to make sure that what's inside the radicand is indeed the same, and this would just be a plus b square root c. Okay, your whatever's under the radical sign doesn't change. It's kind of like a common denominator, doesn't change. And this can also be written as a over c root b over d. And that may come in handy if b is 90 and d is 10. You can't take the square root of 90. You can't take the square root of 10. But 90 divided by 10 is 9, and then you can take the square root of 9. Okay? So these are little tricks that may help you get to the final answer better. Okay, so this example has a mix. So first of all, we can work with these two, and that would be 35 root 18, right? 5 times 7 is 35, 6 times 3 is 18. Okay, and we'll simplify the radicals in a second. Okay, now again, the square root of 42, not so nice. Square root of 21, not nice either. So you think, oh, I have to leave that there, but no, this just works out to be the square root of 2. Okay, now that's not nice either, but I've made that look a little cleaner. And then now I can work with the 18, and the 18 is 9 times 2. I always try to put a perfect square times whatever's left, because then the 9 comes out to become a 3. And 3 times 35 is 105 root 2 plus root 2. And remember, there's a 1 there. That's 1 root 2. So this would give me the answer of 106 root 2. Okay, let's skip this example. Okay, rationalizing denominators. When you rationalize the denominator, you're removing all radicals from the denominator, okay? There's two cases. When it's a monomial denominator, very easy, and binomial, we want to multiply by the conjugate, okay, which is the opposite sign in the middle. Okay, so for monomials, all you want to do, now even this case, I mean, you could have right from here just multiplied by, right, square root 20, because when you take the square root of a times the square root of a, you get a, and that got rid of the radical sign there, so that's all we want, right? And then you can simplify after. You don't have to simplify before. You can simplify after. And we'll do some of these together. These are just quick examples, so you have reference to them if you want to. Okay? Now, when you are multiplying by the conjugate has a really nice way of not having a middle term. Okay? So, if a minus b times a plus b. See, those are conjugates. And when you multiply them out, you'll get a squared, okay, plus ab minus ab plus b squared. So you get a squared plus b squared. Minus, sorry. This should have been a minus here. Okay, so if anything, if a is a square root of something, you'd see squaring gets rid of it. Okay? And there's no middle terms, so you will not be left with radicals in the bottom. So here's a good example. Say you just were doing a long question, and your last step was root 6 over root 5 minus root 2. You've got to multiply, if you want to get rid of radicals in the bottom, multiply by root 5 plus root 2. Root 5 plus root 2. Okay, so we multiply these two. That would be root 30 plus root 12. And I've already shown you that the middle terms will not be there, but you can see root 5 times root 5 is 5. And then negative root 2 times positive root 2 is minus 2. And root 30, any perfect squares in there? No. How about root 12? 4 times 3, right? So the 4 can come out, become a 2. So plus 2 root 3 all over 3. Okay, so again, review, right? You have to do radicals in grade 11 as well. Okay, now this one here, it doesn't have 2 radicals in it, but it doesn't matter. If there's 1 radical in that binomial, you will still get rid of it by multiplying by the conjugate, which is root x squared minus 4 minus x. Okay, now the top will give us 12 root x squared minus 4. And yeah, this one's even debatable if you want to bring it in, because then I just have to factor out after. But then sometimes it's easier for me to say because I know what the final answer looks like, but I think most people would try to get that in there. Now on the bottom, remember these two, when they multiply each other, they will just get rid of the radical sign. So you got x squared minus 4. And the middle terms will cancel when you're multiplying by the conjugate. So you can trust me on that, or you can try it again. And then you'll be left with the two last terms. So that's minus x squared. Okay, and this one conveniently does this for us. So at this stage, some of you might be saying, well, why did you even multiply the 12 in? Because you could pull it back out again, and then you'll factor. And sometimes hindsight's 20/20, right? But if I want to now factor this out, because if I could have combined some stuff there, then that was a good step. This one I actually couldn't combine anything, so it looks like a waste of time, but you don't know that ahead of time, right? Did I mess something up? What? If I did, then I probably wouldn't have noticed this, because I could have put x minus 2, x plus 2, and then minus an x squared. How about I get it all together? So try and cancel first. In the radical? Well, if I do that, it's not going to accomplish anything, because if this was x minus 2, x minus 2 up here, then I could pull one out, right? But x squared minus 4 is x plus 2, x minus 2, so I can't even pull one out. Okay, so this is just going to, I'm left with negative 3 with brackets x squared minus 4 minus x. Okay, so now we don't need example 3, but example 4 says multiply the numerator, okay? And even at risk of doing too many examples today, let's just do example 5, because this one's just horrible and ugly, and if you can do this one, you can do the one before it, okay? And this one doesn't have any relevance right now, but this is a formula for finding, this is a limit formula for finding the slope at any place on a curve, okay? And so there are times that this is going to say find this limit when h goes to 0, when h approaches 0, and you can't do that. So there's a way that you can actually do some work and substitute 0 in, okay? And we'll get to limits soon, but I'll be referring to this. I'll go, remember you guys when we had to rationalize the numerator, when we did pre-calc, this will be the exact formula that we'll be talking about, okay? So I want to get rid of radicals. The actual goal that you don't even realize, I got to get that h out of there, okay? That h is causing me problems because I have when h approaches 0, I can't put h to 0, I'm not allowed to divide by 0, but if I can cancel the h's out, then I can substitute 0 in and actually find the slope at that point. So we are going to multiply by root 2x plus 2h minus 1 minus root, or plus, sorry, want the conjugate, 2x minus 1 all over 2x plus 2h minus 1 plus root 2x minus 1. Okay, so just usually sometimes I'm so used to doing the minus 1 here because it's always plus in here, but this time this is the minus. Always do the opposite. If you don't do the opposite, you will have middle terms. And obviously that has radicals still, and that doesn't help me. Okay. So when we multiply these two together, right, we're just going to get rid of the radical sign. So we'll have 2x plus 2h minus 1 minus, now we really got to be careful, right, with that minus, so I'm going to do brackets, 2x minus 1, and that's all over h times root 2x plus 2h minus 1 plus root 2x minus 1. Okay, now up top we have 2x minus 2x, so that'll be gone. We have negative 1 minus negative 1, so that'll be gone. So all I'm left with up top is 2h over h times root 2x plus 2h minus 1 plus root 2x minus 1. See, even at this stage, I still can't plug in 0 yet. I know some of you guys are going, why do you want to keep plugging 0 in? Okay, and again, you'll see why later. But as soon as I do this one little step, and my final answer would be 2 over 2x plus 2h minus 1 plus root 2x minus 1. See, I can substitute 0 in now and would not make this thing unsolvable. So just be careful. Look for the numerator or denominator when asked to rationalize. Okay, so lesson 3, 1, A, D, G, J, M, O, 2A, C, 3B, E, 4A, C, 5F, and 6B. Okay, so within A, or number 1, there's ones I'm missing, and within 2, this is the minimum you want to do. All of you have to decide at what point how many you want to do for these. But these, I've kind of made, this is like the bottom of the number you want to do to be able to understand these concepts. We're spending actually 10 classes on pre-calc because it's super important, because you sure don't want that to be in your way when you are trying to do derivatives or antiderivatives or finding slopes and doing all the trig